Okay, here is PreQuest 6466 number 3. PreQuest 6466 number 3. All right, so the first problem says convert to rectangular coordinates. And it's 6203. Now remember, this means this is r and this is theta, and you want to find x and y. These are the super simple ones because x always equals r cosine theta, and y always equals r sine theta. Always, always, always. So somewhere, and I've asked you to do this about 15 times, I know, but somewhere in your notes or somewhere, have x equals r cosine theta, y equals r sine theta. Have this written down, put in boxes, because that's how you convert from polar into rectangular. So it's super simple. You just type it in on your calculator. So 6 cosine 203, negative 5.52, and 6 sine 203, negative 2.34. And that problem is done, my friends. That's all there is to it. Now, I want you to skip down to number 4, because number 4 is exactly the same situation, except we're starting with a number. Instead of an ordered pair, instead of a point, we're starting with a number. And so our answer is going to be of the form x plus yi. Since we have an I here, we're going to have an I in our answer. It's not an ordered pair. It's the same x and the same y, though. So to find the x and the y, it's x equals 3 cosine 127 and y equals 3 sine 127. If you are finding x and y, this is how you do it, period. Doesn't matter what the format of the problem is. If you want x and y, you type in 3 cosine 127, negative 1.81, and 3 sine 127, 2.40. So we do problem 1 and problem 4 exactly the same way. The only difference is the way you write the answer, the way you write your x and y, has to match the way it's written in the problem. So if the problem is a coordinate point, x or something comma something, then your answer is going to be x comma y. If your problem is a complex number with an I in it, cosine I sine, I, then your answer has to be x plus yi. Okay, so that takes care of 1 and 4. Now, 2 and 3 are also done exactly the same way, but they are the opposite of what we just did. So problem 2 says we have negative 2, negative 3, which is which is x and y. We have x and y. And we're going to change that into r and theta. So this is not hard, but it's a little bit more involved. So what we're going to do is, what we've always done, we're going to draw a picture of negative 2, negative 3. So here's my 2, here's my 3. I went left 2, down 3, left 2, down 3. Here is my r, and here is my theta. Now the r is easy. R is magnitude. So we just square the first one, square the second one, take the square root. It's the Pythagorean theorem. X squared plus y squared equals r squared. So r, to get r, I'm going to square the first number. square the second number, add them together, and take the square root. So my r is root 13. That is exactly like doing the magnitude of the vectors in the last unit. It is exactly the same thing, the Pythagorean theorem. Now, to find theta, we're first of all going to have to find this angle right here. This guy right here. The one inside the triangle. So I know that the tangent of that angle is 3/2. So that angle is second tangent 3/2. So the tangent of that angle right there, just angle A, the little green angle right there, the tangent is opposite over adjacent 3/2. So I'll do second tangent 3/2. And that green angle is 56.31. So this guy right here is 56.31. So what is my theta? Well, my theta is 180 plus 56.31. I have to go halfway around 180 plus another 56.31. So it's 236.31 degrees. 180 plus the 56. And there's your answer. You started with x comma y. You ended up with r comma theta. Now, problem 3 is identical to this, except the original problem starts out as a number. So this is your x and this is your y, but you are going to change this into r cis theta, r cosine I sine theta. So we have to find r and theta, and we're going to do that. This is problem 3. We're going to do that exactly the way we did problem 2. So we're going to draw a picture. So I come left 4, up 7. This is r, which you should have no trouble finding r. You square the first number, square the second number, add them together, and take the square root. So r is root 65. Now, theta is this. That is theta. We are not going to be able to find theta right off the bat. We're going to have to find this little angle first. And then we'll do something to it to figure out what theta is. But we got to find the one in the triangle first. So I know that the tangent of that angle equals 7/4. So A is second tangent 7/4. So I'll go to my calculator, second tangent 7/4, and my green angle is 60.26. This guy is 60.26. Now, how am I going to find the purple one? Well, think about it. Use your logic. Are you all the way to 180? No. You stopped too early. You stopped before you got to 180. How much before 180 did you stop? 60 degrees. So we're going to do 180 minus 60.26. So that's going to give us 119.74. And that is your number in polar form. And again, the problem had an I, so the answer will have an I. All right, so now we're ready for the next page. We're going to convert to a polar equation. So we have 3x plus 4y equals 6. This is problem number 5. And we're going to convert it to a polar equation. Okay? That's easy. Remember what I had up here just a minute ago when I erased it? These all-important conversion equations, you got to have those written down somewhere. Ideally, you'll have them memorized. We use them so much. But 3r cosine theta plus 4r sine theta equals 6. Kids, all I'm doing is substituting. I'm substituting this in for x and that in for y. And that's the answer to the question. Done. That's it. Number 6. Go in the other direction. Little bit more involved. You'll recall from when we went through this in our notes and the other practice quests that the first thing we do is put the definition for the function in. So this is a sine, it could be a cosine, it could be a secant, it could be who knows what. But whatever it is, you substitute in its definition. I would suggest that if you don't have those memorized, and you were at one time to have those memorized, but you have them written down somewhere, they're in your textbook, they're on your gold sheet. You can Google them, but get them in your notes so that you'll be able to use it when you need it. Now, once you've done the substitution, the definition of sine is y over r. Once you've done that substitution, then we're going to multiply both sides by r to clear the fraction. We always want to clear the fraction. So that leaves us with this. R squared equals 4y because the r's cancel. We did that on purpose to get rid of that fraction. You'll recall that r squared, if we look at our little triangle here, r squared is x squared plus y squared. So there is the answer to the question. In the Pythagorean theorem, x squared plus y squared equals r squared. So when you see an r squared, you can substitute in, I had an r squared here, I'm going to substitute in x squared plus y squared. And that's it. You have notes. You have other practice quests. You have other quizzes that involve that material. You have lots of resources. So if you're stumped at any point about that, you have lots of places that you can go get some more practice. This is, after all, PreQuest number 3. All right, so now we've got a problem that says Z sub 1 is 5 CIS 23, and Z sub 2 is 6 CIS 100. Okay, now we're going to multiply. The first problem says we're going to multiply those. And the second problem says we're going to divide them. Okay, so there are rules with this. I mean, there's a procedure to follow. It's real simple. When you multiply complex numbers in polar form, you remember that you multiply their r values, so 5 times 6, and you add their thetas, so you get 123. So the answer to the product, to the multiplication, is 30 CIS 123. Now, for the division, you do exactly the same thing, only you divide the r's, and that's going to be a fraction, 5, 6. I just leave it as a fraction. That decimal you'd have to round off, so I think it's better if you leave it as a fraction. And then you subtract the angles, so 23 minus 100 is negative 77. Now, that's a problem, because whatever answer you get here, whatever answer your theta is, it has to be between 0 and 360. So this angle is too small. So do you remember what you do when your angle is too small? you simply add 360 to it. So I get 283. If your angle here, if the angle in this position turns out too small, you add 360. If it's too big, you subtract 360. So this is the final answer of the problem right here. Now, number 8. This one probably involves the most steps of any of the problems. But easy steps, you just have to kind of keep track of what's what. So the first thing we're going to do is convert it into our Cis theta form. Okay? So we're going to convert it. And so instead of having -3 minus I, we're going to have R Cis theta. So I have to find my R and my theta. So I did that on an earlier problem. I'll draw this. I'm going to come over root 3. No, I don't want that negative to confuse you, but I'm going left root 3 and down 1. So here is my R. And here is my theta. This is exactly what we did before. I hope it looks familiar to you. Now, to get R, you're going to square the first one. So you get 3. Square the second one, you get 1. Add them together and take the square root, so R is 2. Okay, now we need theta. Well, we can't find theta right off the bat. It's too big. So we'll have to find this little angle here first. So to find that little angle, I'll say tangent of A, the little angle A, equals 1 over root 3. So A is going to equal second tangent 1 over root 3. I hope nobody's confused at this point. This is exactly what we did back on the first page. So I'll go to my calculator, and second tangent, 1 divided by the square root of 3, and I got 30. So this angle's 30. Now, I wish we were live in person, because I bet some of you looked at this number and this number, and the fact that R is 2, 1 root 3, 2, I hope you could tell that was going to be a 30-degree angle, because that's one of your special angles. But in case you couldn't, this is the work, and that turns out to be 30. That is not theta, though. How big is theta? Well, theta is past 180. So I'm going to have to do 180 plus 30. So theta is 210. 180 plus 30. Now, we are not done. I don't want you to get all excited and put a circle around that. You aren't done. You haven't raised it to the 6th power yet. So, all this preliminary work just got us to the point where now we can use de Moivre's theorem. So remember, de Moivre says we take 2 to the 6th, or we take R to the 6th, and we multiply the angle times 6. That's the rule, de Moivre's theorem. Take the radius to the power, take the angle times the power. So 64 CIS, 1260? Now, if you're taking good notes along here, guys, you have not just done this. You have written over to the side, take the radius to the power, take the angle times the power, so that you remember what you were doing here. We take the radius to the power, we take the angle times the power. Now, this would be our answer, except, were you paying attention a few minutes ago? That angle right there can't be bigger than 360. So it's too big. So I'm going to take 1260, and I'm going to subtract 360. Well, shoot, it's still too big. So I'm going to subtract another 360 and another 360. And finally, it got small enough. So you're just going to keep subtracting 360s until this angle gets to be between 0 and 360. It's got to be between 0 and 360, okay? It's got to be between those two numbers. So you just, if it's too small, you add 360s. If it's too little, or excuse me, if it's too small, you add 360s. If it's too big, you subtract 360s. And this is the answer to the question. Done. Finished. Done with that problem. Okay. Now, we have a couple of graphing exercises to do. So this is problem 9, and we are going to plot the point 3, 5 pi over 6. Okay? Now, first of all, if you look at the graph paper I provided you there, and the graph paper that will, you'll be involved with your quiz, you are in degrees. So we probably should change this to a degree angle instead of a radian angle. So you know how to do that. We've done that for months. Pi is 180, divided by 6 is 30, times 5 is 150. You're sitting there with a calculator. If you can't do that in your head, then type it in on the calculator. 180 divided by 6 times 5. Now, 150, you have a 150 line actually marked on your paper. So we're simply going to put that point on that 150 line on the 1, 2, 3rd circle out. So that is point A right there. On the 150 line, 3rd circle out. Negative 5, 45. This is B. Now that's a problem because you can't have a negative radius. Remember, that first number tells you which circle to get on. This says get on the 3rd circle. Well, you can't get on a negative circle, so we're going to have to change that to a positive 5. And remember, this is a wonderful note to take. Write it out in words so that you remember. When you change the sign on R, when you make R positive, when you make that 5 positive, you add 180 to your angle. So it's not going to be plotted on the 45 line. It's going to be plotted on the 225 line. So we're going to get on the 225 line and go out 5 circles. Right there is point B. When you change the sign on R, which you have to do, R cannot be plotted when it's negative, okay? So we're going to make it positive. When we make it positive, we change the angle by 180 degrees. And then finally, R equals 4 sine 3 theta. Okay, so we've talked about how our calculator should be set. So we're going to make sure that our calculator is set the same way it was before. Make sure you are in polar mode, which it should be if you haven't changed your calculator at all. And our window, and we're in degrees. We've been in degrees for everything, so hopefully you're still in degrees. And then we're going from 0 to 360 with a step of 5. These are my thetas. And then my x's and y's, we're going from -5 to 5 with a scale of 1. So for x's and y's, we're going from -5 to 5 with a step of 1, or scale of 1. That hasn't changed. So if you have left your calculator alone as you've done all the practice tests, then you are fine. This is exactly how I asked you to set it up, and hopefully you haven't changed it. So we're all set. All right, so you're going to type in your equation. R equals 4 sine 3 theta. And remember, theta is your variable button right underneath mode. And you're going to press graph. Now, remember that this number right here is the length of the leaf. So it's kind of hard to tell on the diagonal ones, but these leaves should be 4 units long. So you must be drawing them 4 units long. So your picture should look something like that. Now obviously mine's whopper-jawed because my grid isn't very good. Yours is going to look much nicer than that. But that's the shape. This is a 3-leaved rose. This rose has 3 leaves, and they're 4 units long. And that's the end of that. Good work.